Hi friends, in this video, with the help of by using the Lagrange's mean value theorem, show that we have to prove this inequality. Show that if 0 is less than a is less than 1, 0 is less than b is less than 1, and a is less than b, so here b is greater than a, then prove that b minus a divided by under root 1 minus a square is less than sin inverse b minus sin inverse a less than b minus a by this, and with the help of this inequality show this two inequality. So here we have to use the Lagrange's mean value theorem to prove this inequality. So here I will start the answer. So here answer, let here first I will take one function. Let f of x equal to sin inverse x. So here I will take the function f of x equal to sin inverse x. So here as a trigonometric functions sin inverse x, here now I will take here which is defined on let's say here I will take the closed interval a to b. So here of course b is greater than a, that is a is less than b. So let f of x equal to sin inverse x defined on the closed interval a to b. So here as a trigonometric function, this function is continuous on the closed interval a to b. So here I will write, so first working rule, here f of x equal to sin inverse x is continuous on closed interval a to b. So which is continuous on the R, whole R set of real number, so it is continuous on the closed interval a to b. So here second thing, f dash of x, so f of x equal to sin inverse x, therefore f dash of x equal to under root 1 minus this is x square. So here derivative of sin inverse x is 1 by under root 1 minus x square. Here therefore f dash of x exists for all x belongs to the open interval a to b. So here a comma b belongs to this 0 is less than a is less than 1, 0 is less than a is less than b is less than 1, then a is less than b. So here 0 is not there. So here at 1 this function is not differentiable. At 1 this f dash of x is not defined, but here 1 is not belongs to this open interval a to b. So here 0 open a belongs to open a b belongs to open a b. So here a is not 1, b is not 1, but x belongs to the open interval a to b. So here f dash of x exists for all x belongs to the open interval a b. Therefore f of x is differentiable on ओपन इंटरवल a to b. हम f of x को sin इनवर्स x ले रहे हैं. अगर f of x sin इनवर्स x एज अ ट्रिग्नोमेट्रिक फंक्शंस, सारे ट्रिग्नोमेट्रिक फंक्शंस कंटीन्यूअस होते तो sin इनवर्स x इज कंटीन्यूअस ऑन द क्लोज्ड इंटरवल a b, और f dash of x equal to 1 by under derivative of sin inverse x is 1 by under root 1 minus x square. So here at x equal to 1 this function is not defined. So here f dash of x equal to 1 by under root 1 minus x square. So here 0 by anything is infinity, but here in this open interval a b there is no a or no 1. So here f dash of x exists for all x belongs to this open interval a b which is given in this range. Therefore f of x is differentiable in the open interval a to b. So by Lagrange's mean value theorem, therefore by Lagrange's mean value theorem, there exists c belongs to the open interval a b such that f dash of c equal to f of b minus f of a divided by b minus a. So here now tell me f dash of c. So here f dash of x equal to this, therefore f dash of c equal to 1 by under root 1 minus c square equal to f of b. So here f of x equal to sin inverse x, therefore f of b equal to sin inverse b, f of b equal to sin inverse a divided by this is b minus a. Therefore which is equal to b minus a by under root 1 minus c square, which is equal to sin inverse b minus sin inverse a. So I will give this equation as equation number 1. Now here I want to show first this inequality. So here c belongs to this open interval a to b. Since c belongs to the open interval a to b, This implies that A is less than C is less than B. So here, if C belongs to this open interval AB by the Lagrange's mean value theorem, then A is less than C is less than B. So this implies, so here A square is less than C square is less than B square. So here, now tell me, minus here minus A square is greater than minus C square is greater than minus B square here after applying the negative sign. So now tell me, now I want to add 1 here. 1 minus A square is greater than 1 minus C square is greater than 1 minus B square. Now I will take square root. So here under root 1 minus A square is greater than under root 1 minus C square is greater than under root 1 minus B square. Now I will take the reciprocal of each and everything. Now here 1 by under root 1 minus A square is less than 1 by under root 1 minus C square is less than 1 by under root 1 minus B square. Now here if A is less than B, then B minus A is strictly greater than 0. Since now here B minus A divided by under root 1 minus A square is less than B minus A by under root 1 minus C square is less than B minus A by under root 1 minus B square. Since here A is less than B, therefore B minus A is strictly greater than 0. So here this is less than this is less than this. Just observe equation 1. B minus A by under root 1 minus C square equal to sin inverse B minus sin inverse A. Just put here. Therefore B minus A divided by under root 1 minus A square is less than, just put the value of B minus A. Therefore sin inverse B minus sin inverse A is less than B minus A by under root 1 minus B square, which is your result. So here we will get the result B minus A by this less than sin inverse B minus sin inverse A, which is less than this. So here hence first inequality is proved. Now we have to reduce that. Here we have to show inequality this with the help of this. Now let's say this is your equation number 2. So here we will get the result. Now we have to show this inequality with the help of this. Now here put A equal to, here put A equal to 1 by 2 and B equal to 1 by 4. So here A equal to 1 by 2 and B equal to 1 by 4 in this equation. Now tell me, so here in equation let's say 2, here after that therefore 1 by 4 minus 1 by 2. So here 1 by 4 minus 1 by 2 under root 1 minus A square, that is 1 by 4 less than sin inverse, that is B, 1 by 4 minus sin inverse 1 by 2 less than 1 by 4 minus 1 by 2 divided by under root 1 minus 1 by 16. Now here 1 by 4 square is, now here which is equal to 1 by 4 minus 1 by 2. So here just multiply and divide by 2. So here minus 2 by 4, this is 1 by 4, this is minus 1 by 4 divided by under root, here this is 1 minus 1 by 4, this is 3 by 4, 3 by 4 can I will write, this is under root 3 by 2 less than sin inverse, this is 1 by 4, sin pi by 6 is 1 by 2, so sin inverse 1 by 2 is pi by 6. So here this is pi by 6 less than, this is minus 1 by 4 divided by under root, here this is 15 divided by 16, so I will write this as 4. So now here 2 into, so here I will write this as 2 times, here this is into minus 1 by 4 divided by, this is root 3, this is root 3, and so here this is minus 1 by 4 less than sin inverse 1 by 4 less than minus pi by 6 and less than, so here this is minus 1 by 4 into, here numerator of numerator is numerator, this is under root 15. Now here 2 gets cancelled, so this is minus 1 by 2 root 3 less than sin inverse 1 by 4 minus pi by 6, here 4 gets cancelled less than minus 1 by root 15. Now add pi by 6, therefore pi by 6 minus 1 by 2 root 3 less than sine inverse 1 by 4. Here if I add pi by 6, so it becomes 0, which is less than pi by 6 minus 1 by under root, this is 15. So here this is the inequality, first inequality is proved. Now here we can see pi by 6 minus 1 by 2 root 3 into sine inverse 1 by 4 less than pi by 6 minus root 15. Now I want to show this inequality too. So here with the help of same thing, now here I don't have space, I will use this space. Here I want to prove this inequality here. Now here just here put b equal to 3 by 5 and a equal to 1 by 2 in again equation 2. Here in this equation just put b equal to 3 by 5 and a equal to 1 by 2. So here put b equal to 1 by 5. So here therefore b equal to 1 by 3 by 5 is 3 by 5 minus 1 by 2 divided by under root 1 minus a square, that is 1 minus 1 by 4 less than sine inverse 3 by 5 minus sine inverse 1 by 2 less than, so here b minus a, that is 3 by 5 minus 1 by 2 under root 1 minus 9 by 25. So here which is equal to, now come to here, here 3 by 5 minus 1 by 2, here 3 by 5 minus 1 by 2 which is equal to 6 minus 5 divided by 10. So here 6 minus 5 divided by 10 which is equal to 1 by 10. So here 3 by 5 minus 1 by 2 is 1 by 10. So here this is 1 by 10, 1 by 10 divided by, this is 1 minus 1 by 4, I will write this as root 3 by 2 less than sine inverse 3 by 5 minus, so sine inverse 1 by 2 is pi by 6, so which is equal to pi by 6 less than, so this is again 1 by 10 divided by, now come to here numerator, 25 minus 9, that is 16, so here 25 minus 9 16, that is here 16 divided by 25, so here 16 divided by 25, that is 4 by 25, here this is equal to 4 by 25, so 4 by 5, so 25 square root is 5. Now here numerator, denominator of denominator is numerator, so here 2 into 1 by 10 divided by root 3 less than sine inverse 3 by 5 minus pi by 6 less than, so here 5 into 1 by 10 divided by 4. Now here this is 5, therefore 1 by 5 root 3 less than sine inverse 3 by 5 minus pi by 6, here 5 2, so here which is less than 1 by 8, therefore add pi by 6, pi by 6 plus 1 by 5 root 3 less than sine inverse 3 by 5 is less than pi by 6 plus, this is 1 by 8. So here now here you can observe one thing, so this is pi by 6 plus 5 root 3, so now therefore this is pi by 6 plus, so here multiply and divide 3 by 3, 3, so here 3 can be written as, so here root 3 into root 3, so this is root 3 divided by, so here just observe one thing, so multiply and divide 3 by 3, so 3 by 3 which is equal to 3 can be written as root 3 into root 3, so numerator root 3 and denominator is here, denominator is here 5 is there already, so here this is 1 by 5 root 3, so here this is 5 root 3 and 5 root 3 into 1 more 3, so 3 gets cancelled, here root 3 divided by 15, so here in this way here therefore root 3 divided by 15 which is less than sine inverse 3 by 5 which is less than 5 by 6 plus 1 by 8. So here this is just the adjustment of 3. So here with this you will get the result. Second, so here with the help of Lagrange's mean value theorem, maybe they will ask in the question, show that b minus a by under root 1 minus a square sin inverse b minus sin inverse a which is less than b minus a by under root 1 minus b square. With the help of this we have to deduce these two inequality. One in terms just prove put b equal to 1 by 4, and second inequality put b equal to 3 by 5 and a equal to 1 by 2 in both. So thank you.